Yeah, guys. So as you see my screen, right? In earlier lecture, we went through the couple of first of all the Spark example, right? Something that we not cover in our PyCharm IDE, right? So I told you that we can use expression is one of the expression that we can use when dealing with the Spark data frame. It help you to write the SQL-like queries. If you are interested in, let's say, SQL-like queries in data frame, right? So you can use that data frame. So here I just creates first of all one array, create data frame out of it, and then use this select expr like statement to work on that particular data frame. And then I also explain, right? Let's say you have some file and you are reading that file via spark.read.csv with header true and infer schema is equal to true. What would happen? Spark would detect the schema of that particular file, right? Schema means what are all the columns and what would be the data type for those columns, right? But what if I need the control over the schema, right? Then you need to define a schema for that. And for that, you need to create the start type and start field. What are all the fields that you are having in your, you need in your, you must be knowing, right? What are all the headers that you have in your file? So for each one of the header, you will write those header over here in struct field. Okay. Then what is the data type you want? String type, right? And with this, it would create schema. Now, when you are reading that particular file, you just need to give that schema that you created. And when I just print schema, you see all the headers are with the string. Whereas when I ask Spark to infer the schema, it create the some of the header with integer, string, integer, that sort of data type. So that's what we seen right earlier. And then Databricks, I gave the high level overview, right? It's a data analytics platform, and it's one of the main feature that developer who develop the Apache Spark, they designed this Databricks system, and it support the multi-language, right? You can write the things in Python, SQL. I showed you that with the help of magic command, percent SQL, how you can write the SQL query in Databricks itself, right? And basically all the things that you have in Spark are available in Databricks, but Databricks manage the cluster itself as well, right? So if you are deploying Apache Spark on, let's say, for some cluster, management of cluster is your headache. But if you are using Databricks, s- data Databricks and create the cluster, all the compute and cluster, auto scaling of cluster based on your job execution is all managed by Databricks. So it's preferred over Apache Spark and all, right? As long as you are fine with the paying the cost of this Databricks. So that's what we discussed yesterday, right? And internal and external table creation, I told you, right? First of all, when let me I show you. Let me first of all start this cluster, right? Because anyway, it would take some time. Meanwhile, I can start this cluster. Close this cluster. Okay, I'm just creating this cluster with this runtime. Okay, whatever runtime I have, I will not change anything, and I will just create the compute. So this is how simple, guys, is to in Databricks to create the cluster. And I told you that the moment let's say the cluster would get created, we need to install some libraries because the you might need to connect to external services, right? Let's say we are trying to connect to the Kafka, but how Databricks and Kafka would know each other, right? Some libraries are required. So that library I will install when this cluster get up. So meanwhile, back let back to these things. So I showed you, right? In Databricks, you had different, the moment let's say cluster would get up, you would be seeing all these directory structure, user high warehouse, MNT, file store. These are the directory structure, right? Whenever you are creating any table, like let's say you are using data frame and let's say df.write save as a table, this table would get created into the user high warehouse as an internal table. And if you drop that internal table using drop table name command, right, then table of course would get dropped, but all the data that get created in this location would get also dropped. That's a internal table or managed table we call it, right? there is also another path in Databricks structure, that is MNT. You can mount external source data sources as well, like Azure Data Lake, like AWS, S3, GCP. All these data, all these sources you can mount to your Databricks, so that your compute is at a different place and your storage is separate. So we are dividing here, distributing, basically dividing your compute and storage. So that's also possible, and it have also some good use cases and importance when it comes to the data processing part. In our use case, we are using MNT as a DBFS file system. So Databricks, the way S3 is a file system, right? S3, GCP, data lake. So DBFS is also file system. If you don't specify anything, Databricks will use, if you don't specify none of this, then Databricks use DBFS file system. And then we have file store as well. So what is the purpose of this file store? If you have, let's say, some file and you wanted to upload that file via your browser, right? Just upload some CSV, then this is a location. So let me show you this, guys. Let me click on compute. I think our cluster might be ready. Let me click on a catalog. Just refresh it once. It would take time to replay it over here. Anyway, I think just cluster creation is still in progress. Wait for some time. Okay, so maybe that's what I was trying to show you guys. There are different folder structure and the internal table and external table we talk. So internal table is nothing but if you drop that particular table, right? Let this get open. It's taking time to load. Yep. Anyway, so let me see if I can connect to this cluster. Yeah, this cluster is ready. Now I just connected it. Yeah, it's showing connecting. Okay. So what I was trying to say, what is different between internal table and external table, guys? Let's say I create in earlier lecture, right? Just create this, but I create this row, basically the array, and from that array I create the Spark data frame, and then when I did this df, right, and then when I did this save as a table, it would create the internal table for you, right? I showed you if you do describe extended, it show the table is of type manage or internal. They are the same thing, and it's of type Parquet table. Now, if I delete this table, guys, I showed you, if let's say I delete this table, then my table and files both would get deleted. Whereas the external table, right? See, the same ordered data frame that I have created here, right? This ordered data frame, I have just this ordered data frame. I am doing write mode and all this option, and now I am mounting it to the DBFS location, right? And then I'm creating the external table out of it. How? This is the syntax: create table, external table using CSV option. You need to give the path of your external file location. Infer schema and header equal to 2. I want it to infer schema and all, right? When I did the external table extended command, I see that it is of type external, right? And is provider is CSV. But if I drop, let's say, internal table, files and table both would get deleted. If I drop external table, files won't get deleted, only table would get deleted. That's what we seen in earlier lectures. Okay, so this is what we talk about external and internal table. Now let me focus on this use case, right? Yesterday we talked about this use case. I will quickly again will explain through the things over here. Okay, so in this use case, what we are doing, we have use case of product rating plus customer feedback, right? Right. And then we have middle layer architecture, basically raw, enrich, and business layer, how we are moving data across all each layer. This is what the overall solution that we developed in yesterday's session. We have two producers. These two producers are sending data to these two topics. Okay. Imagine guys, there is another system which is sending data to the DBFS file system. Currently, I have just created it manually with the help of data frame. But imagine there is some other system which is sending data into the DBFS in the form of files, right? Now, what I'm doing in my Databricks, I'm joining stream plus batch. Means what is the stream of data I'm getting from this? It's continuous data, right? Product and feedback is continuous data. Someone is pushing data. My producers, two producers are continuously pushing that data. They are continuously sending data into the Databricks, right? In my Databricks, I'm doing join between stream and batch. Batch data is nothing but this data, okay, which I am getting, which is already there in database file system, Databricks file system, right? Databricks file system. So I'm doing this join, and plus I am doing join of two stream as well, one and two stream, right? I'm first of all doing join of these two stream. The result of this stream would be this stream, and then I'm joining this stream with my batch data. And then I form the tables in an enrich layer. Okay. At an enrich layer, I create a few tables, for example, and then from enrich layer. So here you see, right? Create the enrich layer transformation with the SQL or data frame. It's your choice, right? You can use a SQL or data frame. Then data once data is tables is available at an enrich layer, then you are again applying some query on top of it or data frame operation on top of it and generating the business layer data sets, right? So this is how, guys, overall you will be creating the different tables across each layer, raw, enrich, and business with the help of Medallion architecture. That's what we seen in earlier session. I will quickly take you through the even code base as well, because this was quite complex things. Let me first of all open my PyCharm ID. 1 second. Let me stop sharing for a second, for a minute. Okay, let me open another. New window, right? So let me present my screen. Okay. So in earlier lecture, I created two producer, right? Feedback producer and sorry, feedback producer and product producer, right? What these producers are doing? These producer are sending some data into the your topic, right? Let me take some more data to put over here. Just a second. or even maybe fine, we can go with the current data set itself, right? It's fine. With current data set, maybe at least we can see the one data properly. Okay, not an issue. So see, I have, as you see my screen, my ID, I have feedback producer and I have product producer, in which in each I have some product array. What I'm doing over here, first of all, I have this configuration. This configuration is nothing but to connect to your Kafka Confluent Kafka, right? And then I have this product array. For each of the product in product array, we are sending these messages to this topic in Confluent Kafka. So I need to create this topic, and how we are sending a message to Kafka topic with the help of key and value. What is the key? Key is a product ID. So here product ID is a key, and message, enter message. This message is a value. This is how I am sending message to the Kafka. Similarly, feedback producer. I am having this entire data, right? For basically array. For each of the element in array, I am doing producer.produce in feedback topic. Here the key is a customer name, right? For example, and value is entire message, right? So this is how, guys, we are sending this message. So having said that, let me demonstrate this thing once more to you guys. I will be creating the Confluent Kafka cluster once again. Yep. So this is Confluent Community Edition. Okay. Yeah, I told you that how to log in and how. So basically, you need to give your credentials and start using this Confluent Community Edition. It's nothing but the Kafka cluster. So let's click on a cluster default. Okay, let me click create cluster. Then I will use basic cluster from here. Let me launch my cluster. Currently, I'm launching my cluster in AWS location. Let me launch it. So after cluster creation, you should get some Bootstrap server detail. These detail are used to connect to your Kafka cluster. So let me copy it and let me use it in my PyCharm ID. Okay, feedback producer. Okay, so I just added these things. Feedback producer. Let me add then this producer as well. Okay, I have added. Now, as we know that we need to also create keys to connect, I will use this API key, create key. Okay, key val. Okay, and let me just copy this key. Okay, 1 second. I will be sharing my this Kafka cluster. Yeah. So what I did, guys, I just take the Bootstrap server detail and copy it over there. Now from this Confluent Kafka, right? I'm copying my key, and I will put my key over here. Here also I have. Let me see this side. Yeah, we can stop one of them. Yeah. Yeah. So, and Confluent count. Fine. So let me copy these keys, guys. This is the key I have copied. Let me copy another key from here. Okay, I copy secret as well. Fine. I copy key and secret. Same key and secret I need to move at other place. Feedback producer. So this is a secret and this is a key. Okay, so you have key and secret, and let me just download it for a second. I'm stopping my sharing. Okay, I have downloaded it. Let me reshare once again my screen. Yeah. So as you see once again, so we have cluster overview. I just took what I did. I just I create this cluster. I took the bootstrap server detail from here, and I just move this bootstrap detail server in my both location here plus here as well, right? And then I took this key and val from my, so I just went to that creation of key, and that key is basically username password to connect to the cluster. That's what I created. And now we are will be connecting to that Kafka cluster. But if you see, guys, we also need to create some topic in Kafka cluster. So let's do that. I'm into my Kafka cluster now. Okay, going to topic, create topic. I want to create a topic with the 4 partitions and product topic. I will just click create with the default. Let's skip this. I have created one topic. Let me create another topic as well. I create the product topic. Let me create the feedback topic as well. Okay. Create with the default. Skip. So I have created 2 topic over here. Okay. Now, guys, what we will do? Now we are still this stage. Okay. Our topics are ready. Okay. Let me start my streaming process. So there should be someone who is continuously listening to that data, right? So before me producing, let me start my streaming process. So to start the streaming process, what I will do first of all, if you see this location, I don't have any table right now. And even if you see let's say if you go to the MNT, let me connect to this cluster, confirm. It will take some time to connect. Okay, you have one only checkpoint directory, and in that directory you see you don't have anything. Okay, let this directory is empty directory only, right? If I click on a checkpoint, there is nothing. And now an user and file in file and file store, I have just uploaded some of the file, and these are the file system, guys, that what I was talking, right? Whenever you are creating internal tables and all, it would come over a warehouse directory, right? And if you delete the data and basically table and the files over here, both would get deleted, right? So I have pretty empty things over here. Now, guys, let me create one table. So imagine, guys, so currently see, I'm just creating one table in my Databricks. Okay, very simple command to create a table is this way: create table. You just give this magic command and create table using Parquet. Parquet is a file format. Cluster is not available. Let me attach the cluster over here. Okay, so once cluster attached, let me run it. So this would create, guys, one table, a raw layer, customer information. I can show you the moment it see it just created 5 seconds below before. So if you see, now I got one table, and in database file system, if you go to the user hive warehouse, you see you got the file, you got one table as well. Why no files? Because I have not loaded any data. Now let me load some data. I have loaded some data, right? The moment I would load some data in DBFS user hive warehouse, you see we got some data, right? So these all are snappy parquet because I give the data table should be of parquet. So I create this table. Imagine guys, this is bad data we are getting from upstream. Currently, I don't have any upstream system, but imagine the files that you, the tables that you see right now, this raw layer custom information. This table is nothing but the in the form of some files in DBFS location. Okay, let me delete this then. So this is the table we are having. The batch data. We are getting some batch data once in a day from external system. Now, guys, let me start our streaming processes. So this is what our batch data. Now let join this batch data with this streaming data. For that, what we will do, we will go to our, okay, I can just show you how this table data look like, which I just loaded. Okay, this table have more data, okay, because it's a batch data. For example, it show you basically customer ID, customer name, address, age, and location. All this data I have. It's a simple data set I have. Okay. Now streaming layer data ingestion, guys. The way we copied things in our source, basically PyCharm ID, same way to connect to the Kafka cluster, I need to give those configurations over my Databricks as well, right? So what I will be doing over here, first of all, I'm connecting to my Kafka cluster. Okay. This is read stream. Where I'm pointing to, first of all, first let me just copy this configuration and then I will explain the code. Okay. This is a secret username. This is the password. Currently, I'm guys just putting password in plain text, but of course you will be storing it into the database secret and all, or even like another secret mechanism that such as keyword and other things, right? KMS. So let me just add this password. Okay. Let me copy the same username password in below things as well. And then I will explain you things. So we have this password. So I have copied this password as well and just putting it over here. Fine. Yeah. So what we are doing, guys, streaming layer data ingestion. Earlier we did some batch layer data ingestion. Imagine that okay, some upstream system is loading data into in this particular table at daily, for example, or hourly, and we have now this table available in our database file system. Now streaming layer, if someone is pushing data to this product topic, right? What I'm doing, first of all, I'm connecting to, I am creating the stream by subscribing to my product topic. All these things would be as default, right? I need a secure mechanism, SL, SSL, plain SSL mechanism I need, right? And then username, password to connect it. Starting offset, latest, guys. I need the latest data that is coming to the Kafka topic. Okay, that's what I means the starting offset. Now, guys, the messages that I'm getting in my Kafka, what I'm doing, I'm creating some schema first of all. I told you that, okay, in Databricks, rather than inferring schema, you also have to option to create a own schema using struct type. So I create the struct type schema with product ID, title, category, price with of this data type, integer, string, string type, and double type. So I have created this schema. Next, what I'm doing, product data frame, right? I'm just creating this product data frame, whatever I have, right? Now I am pointing to this topic, right? So what I'm doing from this topic, I am reading value, because in Databricks, sorry, in a Kafka, you store data in the form of key and value. So I am reading that value, casting that as a JSON, okay, converting that as a JSON, okay. Now, once I got this JSON column, because I am creating this as a JSON column, right? So from JSON is a function that help to parse the JSON string into the structure column. So this the column JSON that I have created over here, right? Because over here, right? Because I give as a JSON, means JSON as a column. Now I apply the from function, from JSON function, the column name, and I want this data to get converted as a this type, this schema type. That's what I'm doing over here, right? And just give this alias as a data. Alias is nothing but we give, right? Select employee A and department B. So right, A and B are alias. So here that way I give the alias as the data and select star from select data star, right? Select everything from data. The way I am connecting to my product topic, similarly, I am also connecting to my feedback topic as well. So wherein I first of all subscribing to feedback topic, right? The way I connect it, let me take a marker. Yeah. The way I connect it to my product topic, similarly, here I am also connecting to my feedback topic. Starting offset latest, I want latest data. I create the schema out of it, right? And the same thing on a feedback topic, I apply what value I wanted to get, because in Kafka, you store data in the form of key and val, right? I am casting that particular val as a JSON column, right? And that then I'm using from JSON function to get this column, right? And then on that particular column, I am applying this schema, feedback schema, and just giving alias as a data and select star form. So basically, whatever data will be coming into this topic, feedback topic plus product topic, I will be getting that data in the form of this schema. Okay, feedback schema plus product schema. So that's what the intention over here. Now let me run these guys. Okay, I'm pointing to my stream. The moment, let's say I would run, it just finished. Okay, if you see, this is how your product DF would look like, and this is what your product stream, right? Because see, I gave that I need in product stream. In product stream, what are the product stream we are generating, right? This is how it would look like. Product ID, title, category, and price. Why? Because you see, I'm telling that it need to convert you need to convert this stream in the form of this schema. So that's why I have product ID, category, product ID, title, category, and price. Product ID, title, category, and price. Similarly, let me run this one as well. Right? And here, if you just click feedback topic, feedback DF, guys, this is the data. If you just see the feedback DF, right? It's a DF. First of all, you got when you are connecting to the Kafka topic, right? You have the key and val, right? And topic name, partition, all these things. But we are mostly interested in this value. That's why in our select expression, we just using this value, and similarly at top as well, we are using just as a value here value, because I need this value, and once I got this value, I am converting that value into this schema in above case, and then the value I got over here, I am converting that value into this schema: customer name, product ID, rating, and review. Customer name, product ID, rating, and review of this type. Okay, that's what we did. Okay, now let's join to this data set. I have raw layer custom information by data and this stream data. First of all, I am creating the table. First of all, I am creating the custom information table out of the table that I have in raw layer, right? Custom info is the table name I am creating, spark.table. Then I am joining two stream, feedback stream plus product stream based on a product ID. If you see my code, my chum code, you have the product ID over here, right? In feedback producer and product producer also you have product ID, right? So I'm joining based on these two ID. right? Product ID. And then the output that I'm getting, that output I'm joining it with the custom information. That's what I have explained over here, right? I'm joining two stream based on a product ID. The output that I will be getting here, the output would be product feedback. The output that I will be getting, that is product feedback, that is stream data. I'm joining that with my batch data. What is my batch data? Customer information. Feedback, product feedback, I'm joining with the custom information based on a customer name, right? So this is what, guys, I'm doing over here, right? Now let me start stream. Let me run this one as well. Okay, it got created. Let me now, if let me see if I have more data to send, because I otherwise, let me just check it if I have, then I can add that one as well. 1 second. Stream. Okay, yeah, nice. 1 second. I got the product and feedback. Okay, nice. I got the both data set. Let me just copy those. Okay. I will share my screen. Otherwise, in single data set, maybe I think it would be difficult to understand for you guys as well. And we'll be not able to create another tables the way we want. So this is a product data set I will be copying now. Entire product array. This entire product array I have, right? If you are seeing my this screen, yeah, entire product array I copied, and let me copy entire feedback array as well. So in feedback array, guys, this I have just copied, right? So I have this, see, I'm joining two stream based on a product ID. This product ID and this I have a unique between these two stream, right? So I'm joining to this stream which are connecting to the, which are going to the Kafka topic based on a product ID, and then that join, I'm joining with my batch data, right? That's what we are doing over here. So now, guys, let me first of all, okay, I share this. Fine. Now, guys, we have connected these things. Now let me connect to, okay, I run already done this. Let me just, okay, yeah. Now rerun it. Now, guys, let's connect to our Kafka topic. Let me click on it. I just doing start. So, guys, it's a streaming data. It's a streaming query. Let's see what happened now. Okay, it started Spark job. Okay, but nothing is there. If I just would run now, select star from enrich layer feedback product. See, you don't have any data, right? Now, over here. Now, let me start my product. I will start the feedback producer, run, and I will start the product producer as well, run. What this two code doing? It continuously sending product. See, it's sending this customer name, all this data to the topic. And this is also sending the same thing to the topic. Now what's happening? Data is going to this top particular topic, right? Now let me rerun it once again. I think stream got stopped. Okay, let me rerun what once again. So what happened if sometime if no data? Okay, we did one mistake, right? I told you that after creating the cluster, you need to install some library, right? So let me go to the libraries and let me just take that libraries. We just install new level, then install. Let me install this library. Now guys, if you see my product feedback, right? This data is there in my topic. So if you see, I have two topic created, right? When I run my producer and product producer and feedback producer, you see data would be here. Earlier it show empty, but it would refresh in some second. Just wait. See, you got this feedback topic. This is what I send data, right? From my code. If you see, it's a feedback topic, right? So in feedback topic, all the data, right? All these names I just send as a key and val over here, right? And similarly, I have created product topic as well. So data is now in topic, right? Let it get load. Data is available in this topic, right? So whatever the when I run my PyCharm code, it it connect to the Confluent cluster and it send data. Now guys, let's me start my stream. This got installed. This library got installed. Earlier I showed you, right? Now without library, you could not. It show you the error message. Kafka stream got stopped. So what we will do now? Let me since I will just rerun this because we just installed library. I am connecting to the my. I'm just creating the stream to the feedback topic and creating this to the product topic, right? Now, once I created this stream, what I will do, I will rejoin these things, okay? What I'm doing, I'm joining this stream plus stream join plus batch plus stream joins. Now, guys, let me run these things. So it's showing the message stream initializing. So it's continuously scanning the data at a source side. And it's now after scanning, this job, guys, will never stop. It's continuously reading to your topic. So you need to make sure your cluster would be available and running in 24/7. That's how the streaming job, because you are doing what you are doing over here. You are connecting to the stream data, and that stream you are writing to some location, right? In this layer product feedback, in this layer feedback product. So and you are getting table out of it. So it's continuously, it would read to those topic, join that data from that topic with our this table, right? The custom info table, and it would continuously looking for new data from the streams. So that's how it's doing, right? And then joining with the custom information. Let me take marker. Okay. Yeah. So it's continuously running. Now, guys, let me run and see if we got the data. Okay. I think data is still not come. Let's wait for some more time. So it's continuously reading that your data. Possibly we can do, maybe we install library once after that uh, stream started. Maybe we need to push once more the data into topic, but let's wait. Otherwise, we will push once more. So currently still you see there is no data in our inlet layer feedback product, right? And this is a job it's running. You see it would grow and it would again start. So it will not never finished. Okay, maybe what I will do, I don't see it's moving, right? Let me start. Let me send some more messages. Okay, what I will do, I will just send, I will just run feedback producer once more and product producer. Okay, I run this. Now just wait, guys. Let me see if data is there. Okay, data still not there. Let's wait. It show it's moving now. Looks like it's reading that data, right? It got when I started. Earlier we installed library at later stage, so that's why I think we don't got data. But now I think it's moving, right? The moment it finish, then see again it would start. Let me see if we got data now. See, we got these records over here. We are querying. I think we should got this data now. Let me query it. I am running my second Spark job. Water data I'm putting over in two table. What I'm doing, I'm reading this stream and creating table out of it in this location, in this particular location, right? With this table name. Should get data. Yeah, see when I run now, I got all these records over here and all 10 rows that I push from the my streams you see over here. Now what we can do, guys, we can now this is how things would happen, right? At any layer, you'll be connecting to different source, Kafka, database file system, right? Databricks file system, for example, and creating the enriched data out of it. Currently, I just create one table, but you in actual project, you will be creating multiple tables. And on this table, then you will be further querying or applying transformation to generate the business tables. So we will see some table to create out of this table. So now let this get continuously in running state. What I will do, I have this data now, right? Over here in my enrich layer feedback. Okay. What I will do, I will just do so at let's say rather than querying data at an enrich layer, I can even query it, not an issue. But you can query just for your testing purpose. If you wanted to query data at an enrich layer, this is how guys you would query your data. And you can see what are all the category, what are all the location, what are all the average rating of my this data. But I'm more interested in business level layer table creation. So let's say I wanted to spot underperforming category, right? So this is simple query I'm writing where I'm just selecting the category product name, right? And I'm doing group by category and title. And then on that group by, I'm just taking the what on this group by column, I'm just taking the count of total reviews, right? It's rating, right? The average rating and average price. So basically average rating and average price for each product and round it to two decimal places. That's what we are doing over here, right? If I create this table now, once more, category, okay, I think it not took, it don't allow to add something over here. Let me just move, let me just move this one as well. All right, yep. Let me create this. Let me, yeah, I think there was a comma, yeah. So I'm creating now business layer product insight. So from enrich layer feedback. So whatever data we streamed, right? On that data, on that particular table, I am creating this business layer product insight, right? Table got created. Let me run this table, the query on this table. Now you see with the help of this query, we are spotting underperforming category. For example, you see that, okay, average rating for each category and product name, you are getting the average rating, right? If you, for some of the category, you are seeing, let's say 3.5, maybe we want some more review, right? So this is good. This could be the one of the product wherein you want to your business needs some more attention so that you can get more sale on that particular product, right? So this is how basically this is what we are trying to generate insight out of this data. Let me see the understand the customer sentiment as well. If I just query these things, Okay. In this case, I don't have any underperforming things. Okay. All the records are with more than 3.0. Okay. But if you, if in your data set, let's say you have some, so here I am creating this table. What I'm doing, I'm creating this table out of enrich layer, and I'm checking if rating is less than 3, or in review, if let's say I have some word like bad or anything like this, right? So, so, but in our case, none of the data have that sort of things. If I just run select query, you should not get anything, right? Okay. Dynapol. Interesting. So how we got over here? Oh, sorry. See, in earlier things, we have just created the table, right? Not run the select query. So I think there was one data set, only one entry we have, Dynapol, with the 2.5 rating. You can see the same thing over here as well. If I show you my code, feedback producer, Dynapol, right? You see 2.5 rating. Same data we got in my here as well, right? And if you see, we also took the other detail, right? Customer ID, address, age. How we got this data is not in topic. This data we got after joining with my raw layer data set. So if you see, right, this join we apply. This join, whatever join we apply, right? Let me show you. This one, right? We join customer information with the stream data. And this is how, guys, if you see my this entire data set, you got customer name, address, and all these things are coming from my static data, right? Because of course, static data won't get changed frequently. So here, if you see in business layer, I will just go to that same Dyna all things. Okay. I create the table, and if I run this query, you see all the data I got from the topic, right? Customer name, product ID, title, and other thing. But its address and all I got from my static or batch data, right? Addresses and all. So this is how, guide, I'm getting complete information of the particular customer, his address, and how I can improve my services over there. Plus, on the same enriched layer data, I'm again applying some query. Okay, simple identify top rated product by region. Okay, if I just run this query, create table, table would get create. Okay, now let me run this query on this table, business layer top product by location. See, I got this location, basically San Jose, right? LA and other locations as well, right? So top in each location, what are all the average rating I'm getting, right? And for the specific title, for which title or for which particular product, right? So this is how, guys, I'm getting the entire information about identifying top product by each region. So what we are doing, guys, over here, I'm joining stream plus stream data plus stream plus batch data, that is custom information. Batch data, I'm joining in custom information. I have customer ID, customer name, ID, address, other things, right? So in stream data, I'm having the feedback from the two stream, right? This two stream, and then I am joining this output of two stream with the batch data and creating one in this layer table in my case. But yes, in actual project, you will be creating the multiple tables, right? And on those tables, then further you will be writing the query and generate a business layer table. That's what we see end to end. And I just thought to maybe repeat it because it was some complex things, right? So this is how, guys, we seen yesterday. Now, guys, if you go over top, you see my stream will never stop. It would continuously listening. If let's say from producer end, someone would send new data, someone would send, let's say, new data, then it would again come, right? So that's what we seen earlier as well. But yeah, this would happen end to end. Now, guys, let me move to another discussion as well. Okay. So let me stop this stream. Otherwise, this job would continuously in running state. Okay, fine. I stop this stream. Now, guys, we talk about this end-to-end architecture. Okay. Now, guys, this entire architecture, guys, is of based on data lake. Okay. You see this entire data lake, we have a raw lake, enriched lake, and business lake. Okay. Business lake. One of the, and this data lake architecture is well in use in even today as well, but there are some limitation with this data lake architecture. So what are all the limitations? Let me take you through these things. Okay. So see, data, what problem did data lake solve? Okay. Now I'll be talking about data lake, but before that, what problem did data lake solve? Okay. See, earlier your relational database system was too expensive, right? And rigid schema and all. But data lake help you to schema flexibility. You don't need data to be structure type, right? So those things definitely data lake solve, right? And there was no limit when it comes to the storing data. You can uh, you can store the billions of data, right? With in less cost. That was not possible in RDBMS system. It was a very costly things, right? So that problem definitely data lake solve. But in data lake, we don't had acid transformation, right? We cannot do acid transformation, no schema enforcement, right? If let's say, see, one row is adding 10, let's say you have one CS bad data coming, right? And since there is no restriction on schema, you can have one row with 10 column and second row with 15 column. So there, and with this, of course, schema less, having schema less is future, but that also affect the quality of your data, right? How you can get insight from that data. Let's say in, if you have 1000 table, 1000 in 1000 row in one table, and some of the row are with, let's say some of the column, there are, for some of the row columns are, let's say 15, and for some of the row columns are 100, for some of the row columns are uh, let's say 500, right? So it's we can't say it's the quality data, right? So that's was what one of the things. No versioning, right? So let's say, what's the meaning of versioning, guys? Let's say you are reading data from some batch, right? Let's say you are reading some data from upstream system. Let's say batch, there is some batch which is, let me just see a second. Yeah. So let's say you are reading data from some batch, right? And your that external system reading from somewhere else, let's say imagine there is some another system. Okay, it would read data from here and load into your database file system or S3. But let's say it loaded, and it need to, let's say, load 500 files, right? CSV or Parquet. But let's say it load 200 file, and then some in 201 files, let's say it adds some row and then stop. Okay, some exception happen. But now the thing is, there is no rollback mechanism. In databases, we have rollback mechanism, right? Let's say if I'm writing, let's say 1 million row, I can achieve that. Okay, if single row not persisted, rollback entire transaction, right? Or let's say if you are writing thousand row, if let's say one row not got persist, rollback entire transaction. But that things was not available in data lake, right? Is not available in data lake, right? Versioning and all, you cannot roll back to the previous version, right? So that things is not there. Whereas in databases, you can roll back to the specific thing. Okay, I need a snapshot. We can take a backup of databases and can literally go to the earlier stage. So that things is not possible in databases. Sorry, data lake, right? And it's there was of course not support for indexing and caching, which is there in databases, right? So that was the limitation of data. Sorry, that is the limitation of data lake. Now, what is delta lake? Delta lake, guys, support. So basically, delta lake is nothing but the solution built on top of delta file system. So on top of delta file system, the way we have Parquet file system, right? CSV file system, there is a delta lake, delta file system as well. And delta file system and your delta table based on a delta file system. And your delta table, all your delta table, if you are creating, let's say, one solution with the help of multiple delta tables, is nothing but your delta lake. This is how you can think it. It's a delta file system. At a root, it's a delta file system. I will show you detail about delta file system soon. At a very root, you have delta file system, right? And then on top of delta file system, you have then let me write over here. Okay. First of all, you have delta file. Okay. You have delta file system. Okay. Then on top of that, you have delta table. You create a delta table, right? And then on top of that, you create a delta lake. So this is how, guys, this is how it is like. I will show you all these things, but delta, what is the way we have Parquet file system? There is delta file system, and I will tell the benefit of it soon. So it support, what is the main thing that delta file system help? Okay, it support ACID transaction. So now let's say you are doing, you have created one delta table. Okay, and if you insert, let's say 10,000 row, let's say, but if something fail happen at 500 rows, you can roll back entire transaction, right? It's a schema enforcement and schema evolution also it help, right? Plus it also help you in time travel. You can go to the previous state of table or the previous state of your lake. So that's a very good thing, right? If you are, let's say, create one table and some mismatch happen in today's, let's say 9 p.m., let's say 9 a.m., you did some transaction and you see, okay, something bad happens, right? If you wanted to roll back to the something at 8.59, you can do that with the help of delta lake, right? And that, of course, data versioning and auditability is also there. We'll be seeing that. Okay. So now see the architecture that you see now, it's a medallion architecture only, but built on top of data lake. There is no versioning mechanism over here. There is no rollback mechanism. Yeah. So guys, it's not like earlier days if people were developing data lake, they, how they used to do, right? Let's say I have, let's say in the, imagine now this is data lake architecture, and let's say I have this 4 table, right? And I need to update some data into this 4 table, right? But in earlier days, since I'm saying that there was no transaction management and the transaction management, right? Those things. Upsert operation, right? So basically, see, delta lake help you to upsert, upsert, right? The update the record that you found. If let's say you have some row in your table, right? And now you wanted to update those row or add new row in that particular table. So what is upsert? If there is already a row with specific ID, it would update, right? And if no row, it would insert. But in earlier days, how we were doing this upsert operation? Of course, we were doing, but with the help of data frame, and it was more complex things, right? Let's say from a raw layer, I'm getting those data frame, and then at an enrich layer, I have enriched data with no duplicate or anything, right? Now, what I supposed to do? I'm joining this new raw layer, let's say data with the enrich layer data based on that data frame particular ID, right? And then update and then insert into the data lake, insert or overwrite into this particular table. But you say it was not the way we do in databases. How simply we go to database and do upsert operation. But in earlier days in data lake, if someone has to do do these things, what he is supposed to do, he need to use his, first of all, new data. Okay, that's what he wanted to update to, for example, and then he have already enriched data. Okay, enriched data. So if someone has to do upsert operation in this enriched data, what people used to do, they join these two data frame based on some ID, right? And then update the corresponding ID into the enriched layer and then storing that data as a, let's say, so people used to overwrite that particular table, right? So this is one of the things that people suppose used to do, right? It was not like earlier we were not doing at all offset operation, and right, but that we were doing at a data frame level, and it was more complex. So that thing people recognize and they develop the delta lake. Now all the things that you do in your SQL databases, right? Update, transaction management, and all these things is now available in your data lake solution or data table solution, right? So fine. So all these things is now available in your solution, guys. Meanwhile, let me just stop this cluster for now because we don't need it. So I think it would be better to stop this cluster, the Confluent cluster I'm talking about. There is no point to keep it in running state. Delete. Continue. Yeah. Moving to a topic, right? So basically upsert and all these operation were not possible in your data lake. As simple as is there available in, sorry, upsert operation were not available as simple as possible we do in databases, right? We need to in data lake, I just explained that we need to join these two data frame, right? New data with the enriched data, and based on data frame ID, right, you combine and then override the table. So it was not the simple, right? In SQL, how you do, you just write the upsert statement and update all the record. So now that was not possible, but with the help of data lake, that's also possible. Plus in data lake, you were not able to, so in data lake earlier, we were not able to move your data to the previous version. So that's what possible with the help of data lake architecture as well, right? So Medallion architecture with the help of data lake and data lake, right? It's the same bronze, raw layer, enriched layer, and business layer, right? Nothing different in term of architecture. But when it come to main features, right? If you see in data lake, currently the files that we create this entire solution are of Parquet file format. Okay. So if you go to the code set, and I show you that in some of the things that I created the file with the help of Parquet, ORC, or CSV. These files don't support the ACID transaction, schema enforcement, time travel. You cannot move your, okay, I have, let's say, create one Parquet file today, and now I updated it with at 9, let's say at 10, 9:46, I updated it with that Parquet file. I updated with, let's say, 1000 record. Now I wanted to roll back to the earlier version of Parquet file. That is not possible with the help of Parquet file or CSV, right? And data quality reliability, I told you, right? There was not better quality and reliability when it come to the compared to the data lake support all these guys. It support the ACID transaction. It support you the, let me take a marker. Yeah, it support you the ACID transaction, schema enforcement, time travel, and reliability as well, data quality and reliability. So guys, this is what the main difference. So main difference is transaction management. Basically, ACID transaction data lake was not supporting, right? You schema enforcement, of course, was not possible in data lake. Time travel, you cannot move to the earlier version. So those were the limitations. Now, guys, let's move to the delta lake, delta table. Okay. So we'll be creating some table now. So what is delta table? I will just read this thing. That the delta table refer to the table format used by Delta Lake. Okay, an open source storage layer that bring the ACID transaction scalability and streaming support to Data Lake, right? So basically, what it's saying, the same thing I explained, right? It support you the ACID transaction and all, right? And delta table is nothing but the table which is created based on a delta file system. What is delta lake, right? Delta lake is nothing but, guys, all the delta table that you have in your solution, right? You are creating lake out of it, right? So delta lake is open source storage layer that bring the same ACID transaction, right, to the delta lake, which were not possible earlier, right? And you can get this delta lake available in S3, HDFS, right? Database file system or data lake storage. In anywhere you can build this delta lake. So relation I already showed you. So delta file system is at a root level. On top of that, using delta file system, you'll be creating the delta table, and all the delta table that in your solution form your delta lake. This is the simple things. Okay. Okay. It's just terminology, right? A relationship between delta table and delta lake is like relationship between file and file system. The same thing I explained, right, to you. So what happened, guys, when you create the delta table? See, when you create the delta table using, let's say, create table save as a right format delta, this is what command you need to give. The moment you give this command, what would happen? You would see in your folder, you would see this particular folder, user hive warehouse, right? You would see delta lake folder and some Parquet file. For each insert, delete, and merge operation, you would see one more JSON would get created, right? For each operation that what you are creating, it would create some JSON file. What does JSON file stand for? That JSON file say what transaction you did, whether you did insert, delete, merge, whatever you did, right? That's what your this is saying. JSON file is saying. Now you might be guys doing, let's say, thousands of operation, right? And it would create a thousands of JSON file. But what it do, after every 10 commit, let's say you write 10 SQL and commit, and then again you basically commit means the commit operation, right? Let's say you write in one commit, you can write a 10 SQL and just do one commit. So one transaction, you say in this transaction you have 10 SQLs, right? So this way, after each 10 commits, for example, it would create some Parquet checkpoint file. What is the purpose of checkpoint file? Instead of creating these so many small JSON file, it would convert those small JSON file into the one checkpoint file, right? So it would create checkpoint file for faster metadata reading, right? So that is the main purpose of checkpoint file. So I will show you all these things in actual thing now when we'll be do hands-on. So I'm repeating, whenever you are creating the delta table, it would create one folder and folder with the delta log and the Parquet file. Okay, this way. Inside folder, you will see this sort of data, delta log and part, and in part there would be some Parquet files. Now for each operation, you should see some JSON, and after each some JSONs, you would be seeing some checkpoint file. That checkpoint file is nothing but the current information. Let's say after 10, let's say you do 10 commits, the 10 commit might have created, let's say, 20 JSON file. Post that, it would create one checkpoint file, which will contain all the information of your last 10 commits, right? Instead of it scanning again those JSON file, it will read data from the checkpoint file. This is how, guys, important of checkpoint file, right? Now, again, those things, time travel and all, how to move your data to the earlier version and all, I will show you now. Now let's go directly to our use case. Let me connect to Kafka cluster, database cluster. Guys, I have one file over here. File store table customer order.csv. File store table customer order.csv. You can upload from here as well, right? I already uploaded. So let me run this. I create data frame just now. Okay. This is what the schema of this data frame. This is how it would look. Okay, fine. I can even show you how this look like. This data frame look like. See, it's a simple data I have over here, right? Some customer name, product ID, quantity, and order date, right? Now, guys, what I'm doing, I am taking this data frame and storing it as a delta in one of the table. I create this my delta table over here. Let me go to the catalog. You see one my delta table is there. If you go to the DBFS, Hive, warehouse, you see my delta table. You see, same I was saying, there is one delta log folder and there is one snappy Parquet folder. In delta log, you have this file because I just create one from that particular data frame. I just create one delta table. That's why you see I got one JSON and one CRC file. Okay, and there are some SEO optimization file. Our main focus is on JSON file. Okay, it create, so from this data frame which contain this data, it create one JSON file. If you the same location where I just went, if I just do fs command, fs is nothing but, guys, this is magic command which tell Databricks I wanted to do file based operation, not a SQL or Python. It's a FSLS, right? If you want to do ls and particular directory, right? ls operations, Linux ls operation, right? So what I'm doing, for that you need to give this magic command fs and then give this location. You see the same thing I was showing, right? You have one JSON file and one CRC file and few S3 optimization. Our main focus is on SL file, right? Now, guys, I will just, so I did one, I just load this data frame, contain this data into this table, which of type delta. That's why you see I got this JSON file. Now let's see what is there in this JSON file. So if you see, if I just take this, right, JSON 00, because I did the first operation, I got JSON 00, right? Let me run this command. Okay. I just run it. Okay. Let me copy the content, or even if you, without copying, see, you see for that particular operation, right? JSON file that I have, it show all this data. What is the data that we have, right? Minimum order date I have, then quantity I have, product ID I have, then how much time, basically capturing all the metadata, maximum insertion time it take, right? Plus it would also give you the max value of this data set, right? Plus mean value also it would show, right? In some places must be their mean value. So basically what it's doing, it capturing all the metadata of this particular operation that I have done, right? So data plus metadata. Do I have null count? Okay, that information also it capture. Then it's of course of the file path, right? Partitions value, all these things, modification time, all this number of record, three record, right? So all this metadata it capture in the form of JSON file. Now guys, let me insert one more record into this my delta table. I inserted guide number of inserted guys number of rows affected 1. Okay. Now if you see, let me rerun this command now. So it just run. Okay, and I got a new output over here. So if you see over here, I can maybe even copy this. Let it be. So it show you added one record. Okay, what was that? You added 1000 10,001. Okay, I added 10,001. Earlier I just had 1000 record, right? So I added 10,001 Tom and all this data I have added. So that's what it's showing, right? What it just capturing what you add, right? Basically it show that 10,001 that you added, right? And the customer name and all, right? But apart from that, right, it also have the reference of earlier data set as well. So whatever operation you are doing till now, it captured that data in the form of JSON. Okay, I can even, so if you now go to the catalog, let's say compute, sorry, catalog, dbfs, user hive warehouse, user hive warehouse, my delta table. You see, earlier I had only one, I got two parquet, but earlier I had only one JSON file, right? 00. Now I got 001 as well, right? Why I got one? Because I did one insert statement. For each insert statement, it would create some JSON file, and that JSON file contain all the metadata information. What you did, okay? So if you, when you just copying these things, you see it would have all these things, Tom, then how many, basically the quantity and all, right? So if you just the quantity is nothing but the quantity, right? For this, sorry, for this specific operation, what are all the data that you have, metadata, right? That it capture in the form of JSON. Number of record data you added, right? What is the size of record that you added? And all these things. What are all the column names, right? null count, is there null count, and all these things you have, it would create. Now guys, let me do some more insert operation. Okay, let me do 10,000, let's say 5, for example, because I know that Tom 1 already I have some this value with the 10,001. I will add some more record. Okay, 10,005, 2, 3, and 4. I will insert this data. And guys, the way I am inserting over with the help of insert statement, you can also do with the help of data frame as well, right? But uh, uh, just for simplicity, I am writing some simple insert statement. You guys see, if I, though I have added 4 insert, you see number of affected row 1 only, because it just count the last, basically the way that this notebook work, it would just take the output of last one, okay, and just show the, okay, one row affected. But now if I just show you, if I let's say run this command now, let me run this command below. I inserted this 4 record, and if I just run this command now, you see the difference. See how many JSON file and CSV file, sorry, JSON file you got, right? Because of earlier we had only one uh, JSON file. Then I did a second operation, I got a second CSV. But for each operation, right, I got one CSV file. Sorry, one JSON file. JSON 1, then 2, 3, 4, 5. All the JSON file I got. Okay. So so that's what. And for each JSON file, you will be having the details about this entry, what you did over in this entry, what you did in this entry, right? All the detail it capture. Now, let me do one thing, guys. Let me delete some data from this particular table. I deleted this data. Okay, number of affected row 1, right? And now, if I do, see earlier I have operation till 5, right? JSON 5. Let me just take this fs command. Let me create new, let me run it over here, right? Delta log. If I show you, you see, you got one more JSON file with JSON file number 6, right? If you just copy this file name and just, if you just put it over here, can I clear output? Okay, yeah. Let me run it. Okay. You see, guys, it show you what operation you did over here. Number of remove file 1, right? Because you did the delete operation. So it not, so basically, even if you do delete operation, it would create another file. It's not like it will remove some JSON from here, right? It create another JSON file, and now it captured the information of it. Okay. Basically, number of remove files is 1, right? It just captured that information, and then basically the size, particular size of that particular operation, and of course notebook detail and all this information also is copying, right? Capturing, right? So all this information it have. Now, guys, let me run this. I think if I just see my delta table is a delta table I have created, right? You see, I got multiple snappy parquet file, right? Plus in delta log, I have many JSON file which capture the current state of my operations. And then I have, for each operation, I have also some snappy parquet file that what's it created. Now, guys, what I will do, I will add some more record into my particular table. I wanted to show you one thing, versioning capability and all. So I run this command. It show it inserted. If I go in delta table, now guys, earlier we were seeing, let's say some, if I just show you this output, right? It was showing data till 6, right? Now if I run this delta log, it should show you more data. And just execute it. You see, we got the 9 file. After 9 file, it create a checkpoint file, right? After, let's say you do 9th operation, on a 10th operation, it would create another one checkpoint file, because you have so many small file, right? If you wanted to move to the, and uh, managing the small file is a headache for Databricks as well. So what they are doing, all the things, transaction that you made in this 10 JSON operation, right? Basically 10 operations, it capture it in one checkpoint file. Let's see the details of this checkpoint file. Let me just clear the cell output. Okay. If I just run the display, because this checkpoint file is Parquet file, right? You see, on this checkpoint file, you have all the add operation that you done, okay? Plus, in my entire this execution, I just did one remove operation, right? One delete operation over here. Marker. Yeah. So I did just one delete operation over here, right? Delete. So that's why you see only, let me go there, right? So that's why we have only one delete operation, remove operation, and all others are add operations. It just captured the all the details what you read in this thing, right? JSON file. Basically, it just capture all the JSON transaction that you did, right? For each, they just combine all these 10 JSON, 9 JSON into one checkpoint file, and now they show you in add column, you would see what are all the insert operation you did, and on the remove column, it would show you what are all the remove operation you did. So that all information it show. Then guys, just a second. Yeah, sorry. Then guys, let me show you, describe history of this particular, but let's say table. Okay. You see, I did multiple operations, right? And I'm now on a 10th version. So before going to history, I hope this part is clear to you, right? In Snappy, in this checkpoint file, you have the complete history that you did till now in the form of JSON, right? How many files you added, how many insert statement you did, how many rollback, how many basically insert operation you did, how many delete option you did. All this information you have in this checkpoint file. I will tell why Databricks Delta table capturing all this information. Now, I will tell the reason behind it. If I run this command, if I just clear this cell output, for example, clear output, and let me rerun this. Okay. So you see, I got this versions. What are the operations? 10 CSV file, sorry, 10 JSON file I have, and currently I have the 10 version, right? You see a write operation, and there is one, so first of all, I create a table, right? At the very first, we create the table, then we did some write operation, one delete operation, and then we did further write operation. So all the information it captured. So what is the purpose of this information capturing, guys? Let's say if I wanted to move back to the earlier version, I can just click on which version I wanted to move to and revert my table to that earlier version, which was never possible in Data Lake, right? So I'll just show you one more thing. So what I'm doing over here, I create second. Okay, this may be guys, we not need to look into. Yeah, just ignore this the update temp table. Okay, so I have this 10 version, right? 10 version of files. Now what I will do guys, yeah, I got the cause. So update data frame, right? And then I'm using update temp. Yeah. Now guys, what I will do, I wanted to, okay, now I have one table. I got the things. Okay, so catalog and my delta table, right? If I will just show you guys above here, select star from my delta table. You see all SQL. Okay, so it's a magic command. Okay, so you see all the data that I have, 1001, 2, 3, then all this record I have inserted and one delete operation, all these things we have over here. Now I wanted to update some of the record with the upsert operation, right? I was telling you guys in databases RDBMS system, we have the upsert operation, but let's say CS sweep RK file, and there are, let's say 1000 record. If I wanted to update, let's say the some record of this, some of the record out of this 1000 record based on some key, that was never possible in your data lake system, right? But it is possible in delta lake. So when I'm saying data lake system, the table, when I'm saying that it was not possible on a data lake, is nothing but I'm saying it was not possible on a data lake tables, right? But now it's possible on a delta lake tables. So what I'm doing guys, I'm just creating one update array. Okay, it contains, let's say 1001 and 1005 row ID, which is already here, right? 1001 and 1005. Okay, Tom and one, both are with the Tom only. But let's say in one of the row, I wanted to update its customer name as a this one, right? And then I also wanted to update some, it's, let's say, order date. So let's say for 1001, you see order, I have some wrong record in 1001, right? So that I wanted to update for Tom, plus for 1005, I just wanted to update name to some other thing, right? So now let me create, I have created this array, and I from this array, I have created this data frame, and from that data frame, I have created view. This is a way that from data frame, you can just create one temporary view. Let me create this, guys. It got created. I have update data frame, right, with these things. Let me do, guys, now do insert operation, upsert operation. We call this as upsert operation. Merge into my delta lake table as a target, okay, using update temp. What is update temp? Update temp is nothing but this temp, the temporary view I have created, right? Using update temp as a source based on order ID. How I am joining? Based on this order ID. Match. If let's say I got order ID match, if let's say in my update temp, there is one order ID which got matched with, which got a match with my delta table, then update this column, customer ID, product, customer name, product ID, quantity, and order date. When not match, insert that record. That's the same thing, simple thing I'm doing. Okay, let me run this SQL query. And now I am updating some of the records over here. It's showing scanning for matching file and writing two files, writing modification. Okay, merge operation it's doing. It started the Spark job and it show, okay, number of affected rows 2. Now guys, let me do, see earlier we had, when I run a describe delta table, we had, no, when we did a describe history, right? Describe history, my delta table, we had 10th version, right? Now, let me run these things. Let me first of all clear this cell output. If I run this, you see, I am on 11th version. I got 11th version, but this time operation is merge. All operation that you are doing on delta table, write, delete, is write, delete, right, merge, all would get captured over here with the version number and timestamp, right? And same also you can see now, of course, whatever update we did, we should be able to see that update, right? So for example, for 1001 record, we added the value that we wanted to add to. So earlier you see, for 1001 record Tom, we had this value 299, ordered it. Okay, and it is wrong, right? How this number can be there? But now after this update, let me just show you. After this update, we are having proper value over here. Okay, how we got this? Because in our, for 1001, right, I have added this thing 2025 0606, 2025 0606. Earlier was there is number which is wrong. Plus, you see, for 1005 we did some operations. For 1005 earlier, if you see, for 1005 also there was Tom name only, right? Now for 1005 record, I have updated that with de- this name, Desi name, right? So this is how we updated that record. Now guys, due to some reason, let's say my merge operation got, I'm thinking, no, there is something that wrong with this merge operation and I wanted to revert it back. In data lake, it was complex things. You read the data in the form of, you read that CSV in the form of data frame, and see, I'm repeating, it was not like it was earlier, not people were not updating the data lake and all. It was there, but the way it was doing, they are reading data frame and then updating that data frame. But at the storage layer, they need to override that data, right? Wouldn't it be nice the way I do the SQL operation in databases? Then it would be more better if I can do the same sort of SQL operation in data lake as well. And that's how this delta lake come in. Now, if I wanted to, I did some upsert operation, but let's say I wanted to revert back to the earlier version. So I showed you we are now at a 11th version, but I wanted to move to the 10th version only, right? So at the 11th version, you see, we are having this data. Let's say for 1005, we have Desi name, and for 1001, we have this record. Now I wanted to revert back to the earlier version. Let me show you guys. Let me clear output. Spark.read format delta version of 10th. Okay, and this is location of my files, right? All my, if you go to the catalog dbfs, you see user hive warehouse, you would be seeing all these delta table, basically this Spark file and all this multiple CSV and JSON. Fine. Now let me close this. Now let's say I wanted to move back to the earlier version. I will just show you. So using this syntax, you can roll back your table to the earlier version, and you see we got two Tom. For 1005 also we got Tom, and for 1001 also we got Tom, but with the old record. You see guys how it easy with the help of Delta Lake to revert back to the this is called time travel feature in Delta Lake, right? And you see the way it supported transaction management. Let's say if while doing this insert upsert operation, if single row got failed, it would roll back entire transaction. This was not possible in Data Lake. To make that possible in Data Lake, I told you need to join to data frame and do a whole lot of things. Join to data frame based on unique ID and then override that particular table, which is not something good thing, right? We need some simple solution, just absurd sort of things. So this is how guys, now guys, we revert back to the earlier version, the 10th version. In 10th version, you see we have this number and basically Tom having this number, and we don't have Daisy name over here. For 1005 record, we revert back to the Tom's name only, right? Now guys, we can drop this table, okay? Using, if you see that, okay, you are done with the delta tab, you can drop this table with this command, right? Now, one more final thing. Okay, we create this. the way, see, this table we created in DBFS user Hive warehouse location, right? My delta table. Let me show you drop command. Okay. If I run the drop command, it started, it just completed 2 seconds before. Let me go to the catalog, DBFS. Of course, table I don't have, my delta table I don't have. And if I go to the user Hive warehouse, I don't have that table as well. I lost entire data and file as well. But what if I need those file? Then we have external delta table in Databricks. It's the same internal and external table. The way we were creating earlier days as well, right? Before even Delta Lake. So if you want, you don't, let's say you want that when you are dropping table, your file should not get lost. Then you can create an external table, guys. That's the main purpose of external table. And you can create that external table. Currently, I'm doing in Databricks file system only, but you can do in ADLS, S3, or any cloud storage. Currently, I'm doing for doing in Databricks file system only. Okay. So key purpose is moving the decoupling between decouple storage and compute, right? Maybe you don't want it to just work on a database. You want the data to be stored on S3 or Gen 2 account, AWS Gen 2, Azure Gen 2, right? For that purpose, data ownership, right? Maybe people don't want the data to move to the database. They want data into their S3 environment only, right? So you can create a table, external table out, delta table out of that, right? And of course, to support the schema transaction and all, these are of course all the things that they are there in internal table, internal delta table are available in external table, delta table as well. ACID transaction and right, and support to lakehouse architecture. What is, guys, lakehouse? Lakehouse is nothing but the combination of your data lake plus data warehouse. In data warehouse is nothing but like you are having multiple relational databases, right? You are getting data from multiple relational database into single data warehouse, right? And you can do offset operation, but that was not possible in data lake, right? So basically, what is lakehouse architecture? It's a combination of data lake and data warehouse. So it support both things, right? Earlier in data lake, we were not doing the way operation we were doing in data warehouse, right? In data warehouse, we had option to do offset operation, but in data lake we don't have. So now delta lake support both things. It can handle your unstructured data with no limit, plus it less cost compared to your data warehouse, plus it give you the capability of data warehouse as well, the offset operation and all, right? So let's create some simple external table. What I will be doing, I have this array. On this array, I'm just creating this column. Okay, first of all, I have this data array, and in this array I have, let's say, order ID, customer name, then product ID, quantity, and order date. All these data I have, right? Then I am creating the spark.data frame. I'm giving the data basically a row, right? And these are all the columns. And I'm saving that as a external, what I'm doing, that data frame, write.format of type delta, mode is overwrite, right? And save as a this external location. I told you in early lecture as well, the MNT is mount path. You can mount to S3 or any SS location. Currently, we are mounting to the MNT, right? The enriched layer. So let me do, guys, one thing. Let me just run this cell. See, external delta orders. First of all, let me go to the catalog. I should, let me go to the here, MNT, data lake, right? Data lake and external delta orders. Currently, I have created one delta lake over here, basically a table over here, right? A delta table over here with the external location, right? Snappy parquet is basically because I added a command, that's two insert statement. That's I have those two snappy parquet, and in delta log, if you see, you would be having one JSON because for each transaction it would create one JSON. Now you did one transaction, that's why it created one JSON, and for each row, you see, I have inserted two row. That's why you see two snappy parquet files over there. Now on this location, guys, I'll be creating the table in this way. Create table external table delta orders using delta and the location of my external basically delta files, right? If I create a table, if I just go to the catalog and you should see external table orders, right? If you run the describe extended SQL this command give you the metadata information. You see this table is of type external and provider is delta. Earlier you notice provider was Parquet and file Parquet, but now we have created a delta table. Now, guys, I wanted to show that this is external table. Now, even if I drop this table, right, file format would be still there. Okay, the file would be still there even if I drop this table. But before doing that, before writing any drop command, I just wanted to tell you other thing as well. Guys, let me write this code SQL. Okay, and what is my table name? External table order. I will run this command at the end. Otherwise, I may not be able to show you other things that I wanted to show you. Just will be wrapping now. Okay, I will run this command later. But guys, one of the things you see, I have created a many. If you go over here in catalog, currently you see the DBFS system, MNT, data lake, external data orders. You see some only one JSON got created, right? Now, what if you wanted to delete some? Currently, I don't have more data over here. I can even generate that more data. That's not an issue. Let me generate that more data. Or let it be fine. So what I wanted to show the importance of vacuum command. The amount of files that you are seeing over there, right? Those files, CSV file or sorry, JSON file, right? You might get too many files over there, and you might want to do some vacuum that unnecessary file, right? So you can use the vacuum command to delete all unused JSON file. So what it do, if there are no old or unreferenced files older than retention threshold, it would delete all these files, right? So if I just run this command now on external data order, you see, because I just create a table, I don't have anything to delete, right? So vacuum command don't delete the table, it delete the unreferenced JSON file. In earlier things we seen, right? I showed you, if I run the same command, let first this gets accomplished. Yeah. So if you see, I don't got any result because there is no unreferenced file in my case, right? Whereas if I can even do the same thing on my delta table. But now see, I dropped the delta table, I don't have, but anyway, external table, right? We can go with the external table. So if you wanted to delete in earlier, just before some time I show you, right? For each operation, it would create the JSON file, right? In data lake. Now it might create, let's say, thousands of JSON file, right? And of course it would create a checkpoint, but it not delete it. If you want to delete this unreferenced JSON file, you can run this command. It will delete all unreferenced JSON file older than 7 day. Unreferenced JSON file older than 7 day, and you will be still having your table there. It would just delete the files. It would not impact your table. So vacuum command is just to delete the unreferenced file, guys. But see, in case if you wanted to delete. So by default, it take it delete the seven, it delete the files which are older than 7 days, right? This command. But if you wanted to delete the current files as well, what are the latest file as well, you can run this command, delta retention enable false. Okay, and then clear the cell. Let me clear the cell output and let me run this thing. Vacuum dry run command I am running, guys, right? So dry run is actually command which just tell that okay, it will delete those files, it will not actually delete, right? So that's what the main difference in dry run and actual run. If I just remove this dry run thing over here, it would actually delete the files. I just don't want to do that. So you should always do dry run first, right? Because I not got any response. Why? Because I just create this table now. Okay, and I don't have anything to delete, right? So basically you just need to know, okay, if you wanted to do something, delete something on that moment itself, not need to wait for 7 days, you can enable this command, right? But since I don't have any asset data, you don't see any output of running this command as well. So that's what the main difference, guys. So main key point in vacuum command in Databricks, right? So it retain data files for 7 days by default. Okay, and any unreferenced file it will delete all these things. So purpose of delta table is, sorry, purpose of delta table vacuum command is not to delete the table, whereas it delete the your files. So you see, I just mentioned, right? It delete unused file. It don't delete the delta table. It don't impact your data, right? And it would delete only that data which is older than 7 days, right? Now, guys, last thing I just wanted to show you. You see, catalog. You have this database, right? External table order and MNT data lake, and you have some files over here, right? In our case, we have just one, some two checkpoint file and one, sorry, two snappy FRK file and one delta log. If I would drop this external table, it just finished now. Okay, let me go to catalog. My table is lost, right? MNT data lake external table delta order. But guys, my data is still there. That's what the main difference between external delta lake table, right, and managed delta lake table. In managed delta lake table, your table would get delete if you run drop command, but in external data lake table, it won't get. Your file would be still there. You would be just dropping your table, but file would be still there. So that's the main difference, guys. This is I just wanted to cover end to end today. So purpose of vacuum command, I hope you guys understood that. Okay, it just to basically to delete unreferenced file, right? And if you wanted to delete something on the fly, at that moment itself, you need to enable this command. Okay, currently in my data set, I don't have any as such data that way. So that's why you will not see output. So yeah. So that's all for today's lecture, guys. We'll see you in other sessions. Thank you.